Okay. So now we are working with SRTF, shortest remaining time first. Okay. So we are right now in SRTF, which is a preemptive version of your SJF. SJF stands for shortest job first, whereas SRTF stands for shortest remaining time first, which is quite similar to your shortest job first, but with interrupts in between. So let's see that. So let's draw the Gantt chart for SRTF first. So for SRTF, again, Gantt chart obviously starts at time 0, whether you like it or not. So at time 0, P1 is the only one which is available. So P1 will start initially. Okay. Now, P1 will temporarily be suspended or halted at time 3 because of a new process which is arrived at 3. Unlike your non-preemptive where it was voluntarily allowed for complete, but here we are following a preemptive version. So obviously P1 will be halted at 3. So the remaining time of P1 will be 7 here. And P2 has interrupted at time 3 with a burst time of 7. Now because both have same remaining time here, we are supposed to schedule shortest remaining time first, but both have same remaining time. So when there's a tie here, we'll go back to the basic method called first come first serve. So P1 arrived first, so P1 will be given a chance to continue. The next interrupt is at 4 by P3. So obviously P1 will again be temporarily suspended at 4. So the remaining time of P1 is now 6. Okay. And P3 again has a burst time of 6. So there's a tie again, right? So P1 will again be given a chance. And it will continue till the remaining time or whatever is the next interrupt. Next interrupt is at 12, but we don't need so much because remaining time is only 6. So it will continue till 10. So P1 has completed now, right? Now, because P4 and P5 are yet to arrive, I can't stay idle. So P2 and P3 will again be given a chance because they are in the wait queue right now. So I'll push them to the execution queue. But before pushing them, obviously I'll have to check which one has shortest remaining time. So P3 has shortest remaining time in comparison to P2 and P3. So obviously P3 will be scheduled first and it will temporarily halt at time 12 because P4 has arrived. Now, obviously P3 has completed 2 units of time. So the remaining time is 4 here. Right? Obviously in comparison to P4, 4 and 1, if you compare, P4 has a shortest remaining time. So P4 will be given a chance. It has only 1 unit of time, so it will continue till 13. And P5 hasn't yet arrived. So I'll go back to the queue. So P3 has completed, P4 has completed. So it doesn't have a remaining time here. And P1 has already completed. So it doesn't have any remaining time. So P2 and P3 are in the wait queue. So among P2 and P3, P4 has a shorter remaining time, 7 and 4, as you are able to see. So P3 will again be given a chance. So P3 will continue for 4 units of time because it has a remaining time of 4. And anyway, the next interrupt is at 18. So I can continue till 17. There won't be any problem. So it completed. And obviously there's only one process in the wait queue right now. So P2 will be given a chance, right? But it will temporarily stop at 18 because of P5 which has arrived. There's an interrupt. So the remaining time of P2 is now 6 and P5 has a remaining time of 5. So obviously P5 has a better remaining time, shortest remaining time. So P5 will be given a chance. Okay. Now after 18 there are no more interrupts. So it is as good as your non-preemptive again. So you are voluntarily allowing P5 to continue till 23. And obviously this is 0, and the remaining time of P2 is still 6. So it will continue till 29. Okay, now as per this, again compute your wait time and turnaround time for each of these processes. So like I said, again, you can first compute your turnaround time and then come back to your wait time. Turnaround time is simply completion time minus the arrival time, right? So that would be, let me use a different color here. Yeah, so P1 completed at 10. So 10 minus the arrival time is 0, which is 10. And then P2 completed at 29. So 29 minus the arrival time is 3, which is 26. P3 completed at 17. 17 minus the arrival time is 4, which is 13. Then lastly, there's one more. Okay, P4 has completed at 13. So 13 minus 12 arrival time, that is equal to 1. And lastly, P5 has completed at 23. 23 minus the arrival time is 18, that comes up to 5. So you have sum of all this, get your average turnaround time. So sum of all this divided by total number of process, that will be 36 plus 13, 49, 50, 55. So 55 by 5 number of process, that is 11. Okay. Now similarly, go for similar to how we have done in the priority preemptive version. Wait time can be computed using a simple formula, like I said, which is turnaround time minus the burst time. So you would get P1 as 10 minus the burst time is, right, then followed by 26, the burst turnaround time. So 26 minus the burst time for P2 is 7, 19. Then 13 minus the burst time of P3 is 6, followed by 1 minus the burst time is 1, that is 0. And lastly, followed by turnaround time of P5 is 5 minus the burst time of P5 is 5. So that is 5 minus 5 is equal to 0. So the average wait time will again be sum of all the wait times divided by the total number of process. So that would be 26 by 5, which is equal to 5 point, yeah, so 2. Okay. All right then. Let's get to round robin next.